Okay, I want to thank everyone for taking time out of their busy days to come here and listen to me spout off about cows again. And I want to thank Artex for inviting me to this opportunity to share with you a new concept in ventilation. I've been very impressed with Artex from the beginning because not only do they want to sell dairy equipment, everybody wants to do what they do, but they want to sell dairy equipment that's right for you and right for your cows. They're truly the group that's brought the pasture indoors. So I like to think that I started Cow Comfort a long, long time ago, and I think Artex was there when I started it. So I want to talk about a new concept in dairy barn design, a positive, naturally ventilated dairy barn. So we call it the all seasons hybrid barn. It has both natural ventilation and it has a new twist in ventilation. Instead of sucking air through barns, it brings air in positively. It blows air into the barns. A little bit about me for some of you that might not know who I am. I'm Dr. Gordie Jones. I'm a country veterinarian. I'm not an academician. I have just been a country veterinarian. And for my first 15 years of dairy practice, my job was to jump out of a warm pickup into a warm dairy barn and fix a broken cow. My job was to be the person who was downstream helping drowning cows, so to speak. And what I found out was that my best day as a veterinarian was often your worst day as a dairyman. So I was hoping you'd have another DA surgery. I was hoping I'd get to fix another cow. Well, that seemed to be wrong. And here in Wisconsin, where I started practice, we used to have more than 60,000 dairy herds. Today, we're under 8,000 dairy herds. And as we started to sell some of those small dairies in the tie stall barns, an old auctioneer taught me one thing. He went into those barns and he did three things in those barns. Number one, he opened the doors and cooled it off for the cows. That old auctioneer was the first one to really tell me cows like colder air. Number two, he clipped and cleaned the cows. And then number three, he bedded them deep, belly deep in yellow straw. The walkways were covered in lime, and suddenly the cows looked gorgeous. And now we invited the public in for the next 3 to 5 days to look at the cows before the auction. And every dairyman to a man told me the same thing. This last week was the most milk their cows had ever given. Pretty amazing. I asked those dairymen if you learned anything, and they smiled at me and said, yeah, I learned I can't afford that much straw. Anyway, it hit home with me. So the next thing I started to do was saying, I'm going to go upstream and prevent these cows from dropping in the river. So I started a quest that started with Cow Comfort. 1986, I wrote a paper on the veterinarian's opportunity to improve the cow's environment. It was the first time in a published paper that anybody had used the words Cow Comfort. So a while ago, I used to be the father of Cow Comfort. Today, I'm probably the great-grandfather. And as you can see, compared to the picture on the screen, I've got my COVID beard. This is what happens with 4 months of isolation at home. Anyway, I started to do Cow Comfort consulting and then facility design, and then realizing that most problems from cows come from either bad environments, bad beds, bad facilities, bad air, or bad nutrition. So I started to do nutrition too. Well, that led me to a career with Monsanto, where for the last 2 years with Monsanto, I was the head of the large herd expansion team. Myself and John Smith from K-State, together as my teammate, co-leaders, we helped large herds everywhere in the US who were interested in expanding. In that role, I helped design the dairies at Fair Oaks. And then when they started to freshen 100 cows a day, I fixed the nutrition and they made me an offer that I couldn't say no to. It was a dream offer to join the team at Fair Oaks, be the nutritionist for the dairy facilities I designed, and be part of the management team at Fair Oaks. And in that role, I spent 6 years together at Fair Oaks, helping make one of the premier agricultural tourism destinations in the US. After that, Fair Oaks teamed up with me and we built a dairy farm back in my adopted home state of Wisconsin. And I built, designed, built, and managed my own dairy farm for 5 years. After spending 5 years at Central Sands Dairy, I stepped down as the manager and I started to consult again. So what you can see if you look at this history is that I either have a 5-year attention span or basically I can't hold a job. All right. The trends in the US dairy industry, in fact, the world dairy industry, over the last 25 years can best be described by the term from Dr. Paul Fricke as change. I headed to Wisconsin all those years ago to walk into a tie stall barn and help a cow in that barn. We started with a few tie stall ventilation tricks, and then the cows went out in the summer to graze. Today, 25 years later, look at the dairy industry. The average dairyman will double their herd size 4 times in their dairying life. Pretty easy when it was 25, 50, 100, 200. Now it's 200, 400, 800, 16, then 32, and then multiples of 3,500 cows. The industry is just changing. All right, here's a good quick look at what I was going to talk about. Naturally ventilated, positively ventilated barn. This is a retrofit in Iowa. Artex did it, and they did an outstanding job in an old facility, bringing fresh air in and bringing in new beds to an open lot dairy. Not an open lot, but a loose housing dairy. And this dairyman went up spectacularly well in milk. But we'll talk about all this as we keep going. Here's the foundation of what I really think is the true in the industry. The management, environment, and herd performance. 47 herds with similar genetics were fed the exact same TMR. The feed was made at one spot. The milk varied in those herds by 29 pounds a cow, or 14 liters for our non-US herds. This was done by Alex Bach in Spain. He convinced 47 small dairymen to make their forages together, and then they fed the same TMR. Non-dietary factors accounted for 56% of the variation in milk. It wasn't the ration. It was what you do at the dairy farm. Feeding management. Feeding for refusals got us 4 extra pounds of milk, almost 2 liters more. Pushing up feed got us 9 pounds, about 4.2 liters more. Stall design, management, stalls per cow, age at first calving, a list goes on and on. But before we blame the nutritionist, remember that we're responsible for 56% of the variation. We can get that additional 30 pounds more milk than our neighbors. All we have to do is make great environments and do good management. All right, here for a quick shot is my home dairy, Central Sands. The front end looks like a Cabela's. That's not a mistake. That's where I spend most of my money. Anyway, here's how you burn up 80 acres in Wisconsin. We'll go past that. What I'd really like to show people is when we show pictures of cows to the world, when people view a seminar like this or your webinar, I want the cows to look as clean as that white cow sitting there. Our cows should be clean, dry, and comfortable. Cows should be in bed. Look at the holding area here. Lots of fans, drop hoses, lots of concern and welfare and care for our cows. All right, here's a pen of 400 cows. You can see a soaker line, you can see fans over the beds, fans over the feed lane, and 400 cows enjoying a snooze in their bed, with one cow probably looking for a bed. Cows are element-centric. That means they do things together. They eat together, sleep together, and go to the parlor together. So think about that as we look at dairies. When cows take a bed, they should take 1 of 3 positions. This is the long position with her legs sticking straight out, 1 or 2, and she should be able to stick her legs out and take this normal position. This cow in the middle, she's taking the short position. She's rolled up in a tight ball, and she'll spend 3 to 6 to 10 minutes in this position in deep REM sleep, and then while the other cows watch for predators. And then here's a regular cow. She's laying straight in the stall, and she has a forward lunge, and she's taking the regular position. All right, no matter where you are in the world, we're going to start to talk about facilities. There are 3 things a cow should do. She should stand to milk, she should stand to eat and drink, and she should spend the rest of her time laying down, chewing her cud. And here in the US, she might ask herself, what will Donald Trump tweet next? But stand to milk, stand to eat, go to bed. If she's not doing one of these 3 things, she's not profitable for you. All right, I want to step back and talk about fans and soaking cows, because across North America, most of our environments where cows are have a high humidity, above 65 relative humidity, and we add fans and soaking to cool the cows. And in fact, a lot of dairymen think that just simply adding a fan will be all they need to do. For the rest of the world, we call them ventilators, and adding another ventilator is something they think they need to do. Well, here's a dairy barn, naturally ventilated, fans over the feed lane, right here, the big fan, a 3-foot basket fan over the beds every 30 feet, and then a water line, this white PVC line. So this dairyman is running fans over the beds, fans over the feed lane, and a soaker line. What's the effect of soaking frequency and fan supplemental air movement? John Smith did this 18 years ago, and it's an amazing paper. Michael Brook and Joe Harner helped him. They took a cow and they put her in a 96, 95 degree environment, about 36 degrees Celsius for you and the rest of the world. And she was breathing 100 breaths a minute for an hour and a half. So that's what she was doing in that environment. And she was certainly under heat stress. And her response was to breathe hard. All right. So now we put a ventilator on her, a fan on her, and we brought fresh air. Now it was ambient temperature air, but we brought fresh, fast moving air over 10 miles an hour. And when we did that, her breaths dropped to 90 breaths a minute. We were not very effective with just a fan. So now what John did was he soaked that cow 4 times an hour. Every 15 minutes, she got completely soaked. And soaking that cow without a fan dropped her breaths to 80 breaths a minute. Evaporative cooling in Kansas dropped her to 80 breaths a minute. Now he put that 4 times an hour every 15 minutes with a fan, and he dropped her breathing down to 70 breaths a minute. Then they did just soaking 6 times an hour every 10 minutes. And that soaking alone was back to 80 breaths a minute. Now soaking every 10 minutes with a fan, whoa, now we got some effective cow cooling. We got her down to 60 breaths a minute. Still not normal. So then they tried soaking her every 5 minutes. Soaking her every 5 minutes got her almost to the same 60 breaths a minute. Now soaking her every 5 minutes with fans got her to 50 breaths a minute. We got her to normal. So what's the take home? The take home here, summary for cow cooling, is soaking every 5 minutes with fans is superior heat abatement. It's our best heat abatement. All right, increased soaking will decrease her respiration rates. It will decrease her skin temperature first, and she will send blood to the skin and decrease her body temperature. So soaking every 5 minutes with 7 to 10 mile an hour breeze is the best heat abatement. Many systems are ineffective. Water restrictions, you can't put so much water in your manure. Airflow restrictions, not enough airspeed, and then not enough frequency of soaking. All right, that's the learning from that. And I wanted to remind us of that. We need airspeed and soaking over most of North America. Now let's talk about that brand new dairy building. All right. All dairy facilities are tools. This is a quote I got from Dr. Bill Brickert at Michigan State. All dairy facilities are tools, so tools that let you implement your dairy plan. If you build a building without a plan, then the facility will dictate your management. If instead you understand how you want to manage your cows, then we'll build a facility that will let you implement your plan. Facilities last a long time. so do your decisions. Thinking about dairy performance in your building, I want you to think about three things. I want you to think about welfare and cow comfort. Now, being someone who's cared about cow comfort since 1986, we think of it as cow comfort. You, the dairymen, the nutritionists, the veterinarians, the advisors to dairy farms, Artex, we think of it as cow comfort. The world's starting to ask us to think about it as animal welfare. Well, the fun thing about dairy cows is when we put comfort first, we get performance. All right, next, I want you to think about nutrition and rations. Nothing happens without high quality forage and the delivery and availability of that high quality forage. All right, and then management and people. So in dairy herd performance, we want to bring together the facility, the food, and people. When I help design dairies, I would like to make sure that one person can do a job when it needs to be. The timing job is incredibly important. Timing is everything. And if it can be done by one person at the right time, the job gets done. All right, with that, goals of facilities. You can add to this list. These are a few of mine. We need to get cows pregnant. We need to breed cows. We need to be able to find out if they're pregnant. We need to be able to vaccinate our herds. We need to be able to milk quickly and comfortably, and then move them back to their beds. We need to be able to remove manure. We need to be able to treat cows who need treatment at the right time. We need to be able to deliver food, and the timing and the amount delivered is critical. We need to be able to deliver bedding. We need to have 20 hours of eating, drinking, and sleeping. That means the gate needs to be closed for 20 hours a day. So time to and from the parlor needs to be less than 4 hours. And then we need to be able to move cows to other groups, whether they be fresh pens, high producing pens, low pens, dry off pens, far off pens, close up pens, calving pens, maternity pens. We need to be able to move cows quickly and efficiently. All right. What would you add to this list? Collect embryos, whatever. So you might come up with a few more lists for your dairy design that may be unique to you. All right. The toughest decisions in dairy design are, this one determines almost everything. What bedding are we going to use? Sand or everything else? Sand, solids, deep bedding. Are we going to use mattresses with sawdust? Are we going to use peat moss? The choices are almost endless out there. I've seen almost everything. Chopped paper. You choose the bedding. That helps design the manure system. It helps design everything downstream from there. After bedding, our next shot is, what are we going to do for ventilation? And those historically have been natural or mechanical. Are we going to build a 6-row or 4-row barn? There's pros and cons to each. And if we build a 2-row pen, are the stalls going to be face to face, nose to nose, head to head, or are they going to be tail to tail? Are you going to build a hospital parlor? Another parlor for cows that have non-saleable milk. And then last, are you going to have 2-way or 1-way traffic down Main Street to the parlor? And so you go through these 6 decisions, and they're the toughest. After that, the dairy lays out itself. So ventilation. Historically, we've been choosing between natural ventilation, where we take advantage of both the natural wind coming to our dairy facility and the buoyancy of air. That is, the cow sitting at 101 degrees Fahrenheit, she heats the cow up, the air up, it rises, and new air replaces it. So we need a way for that rising air to escape and new air to come in. Mechanical. Historically, our choices have been 2, wind tunnels and cross vents. And we've decided mechanical ventilation has some advantages. One of the biggest advantages in the cold weather is that manure doesn't freeze in a wind tunnel or a cross vent. Also, we can control the airspeed when Mother Nature doesn't give us airspeed. So we've gone to wind tunnels and cross vents. Here's a wind tunnel. A wind tunnel sucks. Well, let me say that better. Wind tunnels have fans at one end, which suck the air down through the barn. So fresh air enters at one end of the barn. It comes into the barn clean. It keeps traveling down the cows, we hope. And then the air slowly picks up contaminants, the pollution, the ammonia, and the gases and the dust that the cows make. It gets a little dirtier, and we hope it goes out the end of the barn. Only problem is our cows become rocks in the river of air. Air, as it comes through here, hits a cow, wants to go over it, and then really what it does is it wants to go over and down the feed lane. And so we get the most airspeed in most of the wind tunnels down the feed lane. So what we've done in wind tunnels is we've hybrid them. We've added fans to the cow space. So instead of just fans at the end of the barn, we have now added fans back over the beds of the cows. And then the air finally goes out of the barn. Wind tunnels, because of our herd size, have increased in length. So as our pen size gets bigger and bigger, our wind tunnels have got longer and longer. Rick Stowell, Dr. Rick Stowell he's at Nebraska, did his PhD at Michigan State under Bill Bickert, and he showed that somewhere at 400 to 500 feet, we have saturated the air with all the pollution we can carry. So as wind tunnels have exceeded 500 to 600 feet, starting to have completely dirty air, at that end, we can't clean them anymore. So in a wind tunnel, you want to ask yourself, which cow do you want to be? You want to be the cow at the fresh air end, or you want to be the cow at the dirty air end? I'm going upstream. All right, cross vents. Cross vents came along because they answered the problem that we had with wind tunnels. Wind tunnels were getting too long. So now the cross vents, the average cross vent, is somewhere between 200 and 400 feet long, which means the air is not completely saturated. So the air in a cross vent comes in one side, clean air comes in, it starts to go over top of the cows. So instead, we build a baffle. We put a baffle over top of the cow, and we bring air back under that cow, back to that cow. And as air goes through this barn, we bring baffles, and it finally goes out the other end. Now, even here, some air is fresher than others. So we put the high-producing cows and the fresh cows near the inlet side. And in fact, some cross vents have added inlets in the middle and others because we're trying to get fresh air in. Again, which cow do I want to be? I want to be the cow with the freshest air inlet. I would never have any of you work in an office where your coworker got fresh air and you got the accumulated bad air down at the other end. We'd like fresh air for all of our office employees wherever we work. All right, so now, both wind tunnels and cross vents need fans 100% of the time. We've taken over the ventilation. So 100% of the time, all year long, we need to run those fans. And we need a generator for fan backup. If the power fails, our ventilation fails. So we need to add a generator to a wind tunnel and a cross vent. We have a fresh air side, and we have a stale air exhaust side. This is the nature of the ventilation system. It's still controllable and still works very well. But any penetration, by penetration we mean any feeding, bedding, manure removal, will disrupt or could disrupt the ventilation. Now in a wind tunnel, we have to come in one end or the other end. The end down near the fans, if we leave that door open too long, the ventilation is short-circuited and we lose our effective ventilation for a short period of time, unless that employee leaves that door open an extra length of time. So any feeding, any bedding, any manure. Now some of our cross vents have made the box bigger and they come in at the inlet side and then they go down the aisles. So they've fixed this problem of penetration affecting the ventilation. Now, the newest Freestall ventilation hasn't relied on negative pressure. Instead, it's natural and positive pressure. It's a natural positive hybrid. And it's naturally ventilated below 70 degrees Fahrenheit, below 20 degrees Celsius. So from 20 degrees Celsius or 70 degrees Fahrenheit and below, it's a naturally ventilated barn and has no fan expense. At 70 degrees Fahrenheit, which is 20 degrees Celsius, we close the curtains, we turn on the fan, and we positively ventilate for 40 to 60 air exchanges. The barn I'm going to show you today has 60 air exchanges per hour. That means that we completely exchange the air in the building 60 times in an hour. Every minute we have new fresh air in that barn. Okay, no power, no fans are needed below 70 degrees Fahrenheit. Again, that's 20 degrees Celsius. Winter, when we get below 10 to 15 degrees Fahrenheit and manure starts to freeze, we're going to reduce the exhaust out of the open ridge to 4 continuous air exchanges. Most naturally ventilated barns don't reduce exhaust in the winter. Here, we're going to reduce it to 4 continuous air exchanges per hour and prevent manure from freezing. No manure will freeze with a delta 30 in Celsius. Let me be very careful explaining this. So if we're dealing in Celsius and it's 0, we want to maintain 0 in the barn. We can be minus 30 outside. We will have no steaming, and we will have a 30-degree environment, a 0 degree Celsius environment. We can be 30 degrees Celsius. If we think about this in Fahrenheit, we can maintain a 32-degree Fahrenheit building and go down to minus 22, minus 25. That's a 54-degree difference in Fahrenheit. The engineers helped me work this out, and we get no steaming. As you bring in that cold air mixed with the moist air, many dairy farms steam up. Well, with this ventilation system that we've come up with, we can handle a 30-degree differential in Celsius, a 54-degree differential in Fahrenheit, and not freeze the concrete, not freeze the manure. All right. The goals of this new barn, as we designed it, were to have no heat stress. Eliminate heat stress. Number 2, eliminate cow bunching. I'm going to get my herd here for a minute. When cows are under any stress, they bunch together. This is my bunch. If you can see my herd, they're all bunched together. If they've got biting flies and they're bunched together, they've reduced the surface area and flies can't get between them. Well, in heat stress, cows bunch. Why? Well, evolutionary, if you will, they were developed on the edge of a glacier outside. And when it got hot, above 20 degrees Celsius, above 70 degrees Fahrenheit, they went to the shady spot. They went to the dark spot. So even though you provide heat abatement in a naturally ventilated barn, it's still hot. So these cows all travel to the middle, to the dark spot. In the morning, the east end, when it lights up, these cows avoid the east end and they head to the dark. Well, the beauty of wind tunnels and cross vents are we've curtained the barns up, we've controlled the lighting. There is no dark spot. It's subdued lighting, and cows like subdued lighting. So they don't bunch. Well, the goals of this new barn were no cow bunching, and then no frozen manure in cold climates. Those were our goals as we laid out this barn. And then my personal goal was to have fresh air everywhere for all cows. I owed it to these cows. Most of you are building barns today that will last another 30 to 40 years. Our barns have lasted that long. What's our great performing herds today are at 100, 110, 115 pounds, 45 to 52 liters a cow. Where are we going to be in 10 or 15 years? I want you in a facility that will allow those cows to perform at 120-pound average, at 150-pound average, because we're going to get there. All right. Here's our naturally ventilated barn, and we've added positive ventilation. We're bringing air in from one side completely in, and we're bringing air in from the other side. So those three Holsteins together at the feed bunk, they are getting fresh air coming in positively. So whether they're there, or whether it's this Jersey down at the other end, or this Jersey at that end, or this Jersey, it doesn't matter where you are in this barn, we have clean, fresh air. So this barn has met one of my personal goals, and that was no matter where you're at, I've got fresh air for all cows. All right, here's the concept of what I thought the barn was going to look like originally before I had anybody build it. We were going to have fans over the feed lane, fans over the beds, and over there on the sidewall, I was going to have two 48-inch fans, and they were going to bring air in every 25 to 50 feet, and they were going to bring in the air exchanges I need. Fans can do two jobs. Fans can exchange air, and fans can provide airspeed over cows. Now, these fans that you see here over the beds and over the feed lane are airspeed fans. The fans on the sidewall I have here are exchanging air. So it was going to take two sets of fans. When we hit 70 degrees Fahrenheit, 20 degrees Celsius, we were going to close the curtains, turn on the ventilation, and then use these fans. It was going to be positively ventilated with fans over the beds and fans over the feed lane. When we started to figure out this barn, we said, wait a minute. Those big fans were blowing feed and bedding and water all the way into the middle lane, particularly bedding and feed. So they were too powerful. So we started to use smaller fans in our experiment. We ended up with a 3-foot fan. If you notice here, this is what we ended up with. Along the sidewall, we have 3-foot fans every 10 feet. I've got 3-foot fans here every 10 foot. So 1 meter fans every 3 meters. And they are providing air exchanges and they're blowing into the cow space. So here's what's happening. They're blowing air in, exchanging our air and giving us 60 air exchanges. And they're hitting the occupied zone where cows live. So where cows are laying down, they're providing airspeed. These fans are doing both jobs, airspeed and air exchange. And here's what's happening. This 36-inch fan, 1 meter with a half horse, tilted at 22 degrees, is providing, well, what it's providing is at the feed lane, it's providing 7 miles per hour. At the bed space, it's providing between 10 miles an hour and 14 miles per hour. So we get 10 to 14 miles per hour in the bed space, 7 miles per hour at the feed lane. For those of you in the rest of the world that doesn't use our system, we're providing 12 kilometers per hour at the feed space, and then 16 to 22 kilometers per hour at the bed space. All right. Now, this is an operational cost in Wisconsin. So a naturally ventilated, this was for 2 360 cow barns. This was done by the UW system by Dr. Nigel Cook's group. And they took this dairyman who was going to put in 2 barns. He was going to have 240 fans for natural ventilation, not going to do air exchanges by fans, just airspeed over the beds and feed lane. And it was going to cost $18 a cow in electricity per year, operational cost. We made the hybrid positive barn. It was going to take 2 barns. We were going to have 1/3 more fans. We were going to provide 60 air exchanges. And for that 1/3 more fans on the sidewall doing what we're doing, we're going to cost $18.60 a cow. So almost the same operating cost as a naturally ventilated barn with fans over the feed lane and fans over the beds. A wind tunnel, it was going to take 2 of them to do the exact same number. They were going to have 46 exhaust fans. They were going to have some circulation fans. and it was going to be 216 total fans. They were going to have an air exchange of 40 per hour, and it was going to cost, because it has to be run year-round, $56 a cow in Wisconsin to run it. A cross-vent barn was only going to be one barn. It was going to take 115 exhaust fans, no circulation fans, the baffles would do it. Total fans in the barn would be 115. They would get 50 air exchanges, and it would cost $46 a cow, similar to a wind tunnel, but a little less. The hybrid tunnel, which is really a hybrid tunnel, which is more fans over the bed spaces, was going to take exhaust fans of 12 and 47 plus 64 circulation fans for 246. It was going to make 40 air exchanges and cost $62 a cow in Wisconsin to operate. All right, so the hybrid all seasons positive barn was going to cost us $1,860. What does that really mean to us? If we have 1,000 cows or 3,000 cows, a natural ventilated barn is going to cost us $18,000 for 1,000 cows, or $54,000 to operate for 3,000 cows. The all seasons hybrid is going to cost $18,600 or $55,000 for 3,000 cows. The wind tunnel is $56,000 or $168,000. The cross vent, $46,000, $139,000. And the wind tunnel hybrid is going to cost $62,000 or $186,000. This came out of the UW Dairy Initiative numbers for operational cost and the weather in Wisconsin. If you're in a warmer climate than this, you'll run, and your temperature, the time of your temperature above 70 degrees is longer, you'll have a higher operational cost on all sections because it's the fan time operating. All right. UW Dairy Initiative, here's the take-home message. We can do this all seasons barn for the same cost as a naturally ventilated barn with fans. So here's the barn again. We had to do an overshot roof to control winter ventilation. If you're in part of the world that doesn't have frozen manure, you just leave an open ridge there. You don't need the overshot. All right, we also added helicopter fans, or the company calls them big ass fans. And we've added them every 80 feet. And their simple job there is, as we restrict the exhaust out of this barn, these fans act as mixing fans. That is, they bring the warm air that's trapped up above and they bring it back down to keep the concrete and manure from freezing. We've got an R6 only ceiling, so that insulation above us isn't much, but it is an R6 ceiling. All right, here's the fans on the sidewall. A 1 meter fan every 10 feet, or a 3-foot fan every 10 foot, a 1 meter fan every 3 meters. All right, here's our exit to the parlor. This is something I'm pretty proud of. This is a 8 meter, 26 foot wide one-way main street, and it keeps the cows cleaner. They don't splash as much manure. You open 2 14-foot gates. You're bringing 28 feet of cows into a 28-foot main street. The cows flow to the parlor at slow speed, but it delivers more cows in less time. The cows get there faster without moving faster. All right, back to the barn. This is summer above 20 degrees Celsius, above 70 degrees Fahrenheit. We've closed the curtains. The fans are operating, and they're providing the air exchange. All right, this is winter. Now in winter, we can close the ridge at the top to 4 inches, 10 centimeters. And along the eave, we've added a second set of curtains. We've added a drop curtain to cover those big holes where the fans are. So now what we have here is 2 inches of continuous eave in the winter, meeting 4 inches when we close this down of continuous ridge. How do you get this math? I'm reminded of Peter, my son. He came home from first grade math, and in first grade he learned math, and he told mom and dad, he said, I've just learned math and it's very exciting. And Mom said, tell me what you've learned. And he said, 2 + 2, the son of a bitch, is 4. Mother was stunned. She says, go tell your dad this. And I listened to Peter and I said, what are you learning? He said, I'm learning new math. And he goes, 2 + 2, the son of a bitch, is 4. And I said, okay, we better talk to the teacher. We got to the parent-teacher conference and asked, Peter's pretty excited about math. And the teacher said, boy, he is. And I said, what are you teaching him? And she said, we're just doing simple addition. And I said, would you explain to me simple addition? And she goes, sure, it's 2 + 2, the sum of which is 4. And I said, never mind, take care of this at home. Okay, so what's it really mean for this dairy building? It means 2 + 2, the son of a bitch, is 4. So when I'm trying to hold it to 4 air exchanges per hour, we reduce the inlet to 2 inches on each side. Those 2 inches will bring in enough air to go out the 4-inch hole in the roof, but you cannot completely close the ridge. If you do, you build up warm air, you build up moist air, and then you let it out. So cows aren't getting clean, fresh air all the time. They're getting warm, moist air, cool air, warm, moist air, cool air. You need to have 4 continuous air exchanges per hour in the winter to get us clean air for the cows. And these numbers come from both Bill Bickert at Michigan State, Rick Stowell at Nebraska, Bates and Anderson at Minnesota. They're the engineering blood. Bob Graves at Penn State, all of the legends of ventilation. All right, here's the fall and spring. So we're above freezing and we're below 70 degrees Fahrenheit. Open ridge, open sidewall, Mother Nature is ventilating this barn. When we get above 20 degrees Celsius or 70 Fahrenheit, we shut the barn and we take over the ventilation. All right, here was a 96 degree, about a 34 degree day in Celsius, 96 in Fahrenheit in Wisconsin. And here's our cows, 96 degrees, almost 100 degrees Fahrenheit, and they're all laying in bed. Remember I said when you show pictures of cows, they should be clean? Look at the white on these cows. Look at their legs. Look at that. This herd has a cell count below 65,000. It's not accidental. It's because the cows are laying clean, dry, and comfortable. 96 degrees, 34 degrees Celsius, and look at them. Chewing their cud, having a good time. All right, now on this picture, I'm on the outside of the barn. Dr. Andy Johnson is inside manning my telephone, and he's taking the video of me steaming it, not steaming it, but smoking it with mineral oils. And so I'm bringing smoke into this fan, and I want to show you that the fan is directed down to the cow space. So not only exchanging air, but bringing 10 to 15 miles per hour to the cow space. The cow's heated up and it goes out the barn. Again, look at a clean white cow there. All right. Now I'm standing in the bed closest to the feed lane and I'm dropping sand. And I'm showing you that the fan has enough power to take that sand I'm dropping and carry it all the way to the feed lane. It's a fast video. I should have taken. Let's look at it again. Airspeed all the way to the soaking feed lane. So we're bringing airspeed to the back end of the cows without blowing the water onto the feed. All right, the goals of this new barn. The goals were no heat stress, no cow bunching, no frozen manure in the cold climate, and fresh air for all cows in all spots of the barn. The goals were achieved. Okay, let's take a closer look at the case study herd where we did the first all seasons hybrid barn. The dairyman was getting 85 to 90 pounds. He wanted to know why he wasn't getting the 110, 115 his neighbor was. They live 3 miles apart. They cut 4 each on the same day. Why aren't I getting what Jeff's getting? And I said, first of all, Jeff has a barn that was built 3 years after yours. So I have a 2-foot higher sidewall. I have better crossovers, and Jeff only has 1 cow per bed. He said, Gordie, I knew you'd say that. He said, I'm going to build a cross vent. And I said, if you build a cross vent, I'm going to lay in the alley, the driveway, and stop the truck. And he said, then I'll solve 2 problems. I'll get my barn and get rid of you. Okay. Hank had 30% overcrowding. So we built the all seasons hybrid barn. It was built. Also, we retrofitted his old barn. His barn was built in 1994. 1994, I helped design it. I had a 14-foot sidewall, not 16. I had 8-foot crossovers, not 4-meter, not 12-foot crossovers plus water. So we retrofitted his old barn. We did both new ventilation, this hybrid all seasons, and we fixed the crossovers. We made them bigger. And at the same time, we gave 1 cow, 1 bed, and we opened Main Street to 26 feet wide. So we did a lot on that dairy that summer. When the dust cleared, and literally the dust cleared, and 6 months later, he was up to 105 to 108 pounds. So he went from 45 liters a cow to 52 liters a cow, or from 90 pounds up to 108 pounds, all within about 6 months. So the advantages of this barn, what are the advantages? Number 1 advantage, in my opinion, is I get clean, fresh air for every cow in every spot of the barn. Number 2, it has the same operational cost as a naturally ventilated barn with fans over the beds and feed lane. It has 1/3 lower operational cost, that's yearly, than a mechanically ventilated barn. The doors can be open or closed with no effect on ventilation. In fact, you can leave the doors open because we're positively blowing air out. You cannot penetrate this barn and affect ventilation. Less real estate. We can now bring these barns closer together. These barns can be side by side because at the hottest time of the year, we're not worried about a wind shadow from the other barn. We're controlling the air. Fresh air in, dirty air out the roof. Okay, they can be built north or south or east or west. We're naturally ventilated. We need to build them east or west, we're learning. We thought 20 years ago that we could build them north and south because we could take more advantage of prevailing winds. It turns out that the sun rises in the east, sets in the west, and we were bringing in heat loads into those barns. So our naturally ventilated barns need to be east-west. Well, the all seasons hybrid doesn't need to because we don't care about the sun below 20 degrees Celsius, 70 degrees Fahrenheit. No generator is needed for these fans. I don't have to buy additional generator power. If the generation fails, if the grid fails, you open the curtains and it's a naturally ventilated barn. And it can be naturally ventilated for 2 to 4 hours while we wait for the power to come back on. We always have fresh air. No wind is needed to assist the natural ventilation. It's simple to operate. Set it at 1 temperature to close and turn on. It's done. No manure freezing, no steaming, with a delta of 30 degrees Celsius or a delta of 54 degrees Fahrenheit. So if you're in Celsius, you can be 0 in the barn and -30. For those of you that live in Saskatchewan and think it's going to get -40, we could be at -10 in the barn. Manure wouldn't freeze. Water would. We make non-freezable water. We run the barn at about -5, -10, and we still get no steaming. Same differential in the Fahrenheit. We run the barn at about 20 degrees Fahrenheit, and then we can go down 54, down into -30, -35 here in the US. So whether you're in North Dakota, Wisconsin, or wherever you are, we get no steaming and we get no freezing over a long, cold, bitter winter. All right, lower construction costs than natural ventilation with fans. Natural ventilation with fans takes 4 rows of copper. 2 rows of feed lane fans, 2 rows of bed fans. This only takes 1 row of copper, and the construction costs are easier to install those fans along the sidewall. And it's only 1/3 more fans. Okay, so those are all the advantages of it. We've done it in retrofits. This is the Artex retrofit of Meadowvale in Iowa. And we've done it in New York just recently in a 6-row barn, because some of you are going to ask, well, can we do this in a 6-row? Yes, we just need bigger fans, not 3-foot fans, but bigger fans with more CFM to take care of the bigger volume of air and to get enough airspeed to cover the beds along the wall and the beds along the nose to nose and take it to the feed lane. So I would suggest, this was just sent to me a couple of weeks ago. They're adding louvers to this, and the louver will direct air to the bed below, and the top louvers will direct air to the nose-to-nose beds and the feed lane. And if we didn't have enough airspeed in hotter climates past the beds, all you have to do to this barn is still add fans along the feed lane. So you can increase more airspeed for that kind of barn. If it got too wide and we weren't getting the airspeed we needed, we simply add feed lane fans. Remembering that at 70 degrees, we can turn these off. Fresh air for all cows. Will this work in a hotter climate? It will work in a hotter climate if your current airspeed and soaking works. All we're doing is providing the same thing. So with that, I'm done with the presentation. We'll look for your thoughts, your questions, and I'm available by email here at gordon.a.jones@att.net. Happy to answer questions. And the Artex team, who have embraced this kind of technology as one more tool in their toolbox, the Artex team is willing to help you and answer your questions. As I tell the world, I love to get email. I just don't answer much of it. No, I'll answer it. And I promise you, in the weeks to come, I'll have a beard that looks like this picture instead of this COVID beard I'm playing with right now. Anyway, with that, I want to again thank Artex for the opportunity to present this to you. I want to thank Artex for their partnership and being in this journey with me or with them. It's been a thrill, and they're at the ready to help you. Thank you.